All right, welcome to Lecture 7, Stanford CS193p, spring of 2025. Today, I'm going to do one more demo thing about data flow. I'm going to warn you, this is kind of advanced data flow, okay? So if you watch this and you're like, whoa, that's too much for me, don't worry. I intentionally leave it till after the last lecture because you don't need it at all in your assignment 3 that you're doing, so don't worry about that. But it is understanding it. It's a really key to understanding how it is SwiftUI is doing what it is doing, right? What it's doing behind the scenes. So I think it's definitely, trying to get your brain around what I'm going to do today. Then I'm going to go back to the slides and I'm going to talk about animation for the rest of the lecture. And on Wednesday, it's going to be all animation all the time demo. We're going to really spruce up CodeBreaker to make it really have smooth user interface interaction with the user, etc. Okay, so there's lots to talk about animation, as you can see up there. So let's dive right into this demo I want to do first. Before I started, there's actually a small feature that I want to put in here, which is, you see, we put these little round circles around the pegs. You remember when we did that? Why did we do that? Well, we did it because otherwise it would have been just blank there, and users wouldn't even have known to tap there. So we had to put something there. But now we have the selection. So I'm not sure we need those circles. And I personally don't like them there. I think it makes the UI not look so clean. So I'm going to remove them. I'm just going to go over here to peg view, which is where we put these. This is where the missing code peg overlay is, right? Where we stroke our peg shape to put that little round circle. So I'm just taking that out of there. Now I still think this is totally accessible to my user. I want my UI to be accessible. I want the user to kind of have an idea what they're supposed to do. Not only because we have this selection here, but we also have the keyboard. We didn't have the keyboard before either. The user sees this and they're like, what's that? Oh, look at that. Oh, I can, oh yeah, and then, oh, maybe I can click here. Oh, I can't. You see, they can rapidly discover how to use the user interface. One other minor thing I wanted to do is to go over here and start organizing our code, because we have quite a few Swift files here now. So you might already be doing this in your assignments, perfectly fine. But I'm going to, for example, select all my model files. I'll even include words in my model, even though I don't use words in my app. And I'm going to go down here and say new folder. I'm going to call this my model. Now, in a serious app, you're not going to have a folder called model because you might have multiple models because you have a big app. There's lots and lots of functionality in there. But it works for us so far. And then I'm going to select all of these views. These are all my UI views. And I'm going to make a folder from this. I'll just call this for now my UI, but again, you might have different views that you're showing, but you can easily, anytime you want, go and divide these things up. Let's make sure we didn't break anything by doing this. Hit a build. Here's our CodeBreaker view. I have it pinned right here, so as we wander around, we can always see what's going on with our UI. The thing I wanted to do here is get rid of view for code. I kind of warned you I didn't like view for code, this idea of having a little func here, that I really thought it should be a helicopter view. And in fact, I already have a helicopter view to do codes. It's called CodeView. The only problem is that my match markers here, this is where my match markers are and my guess button, I kind of wanted to keep them out of CodeView a little bit because this brings things like the game into it. Guess button's got to play the game. So I am going to actually put all this stuff in CodeView, but I'm going to put it in a way that is extensible and parameterizable. So I can put any view I want over here where the match markers or the guess, or I'm even going to put a view up here for my master code. I can put any view I want in there, and it's totally configurable as to what view I put in there. Let's start by moving all of this extra code here, this HStack and all this stuff. I'm going to move that all into CodeView. So I'm going to take this, cut it, get rid of this entirely, go over to CodeView. Here it is. Go to its var body. I'm going to paste this in. And of course, this part right here is this part down here because I'm in CodeView now. Whoops, sorry. Like this. Cut that. Replace this call to CodeView with that. And now I've put everything back into CodeView, including the match markers. But I'm going to punt on this overlay down here. You see this overlay? I'm just going to comment it out for now, and we'll get back to it, because that's the overlay that I want to be extensible, where I can put any view I want in there, absolutely any view I want. It could be match markers, guess, whatever. Now, I used to have this view for code, which is the function I use here to show my master code, my guess, and my attempts, right? That was this view for code. So now we can delete this view for code, and instead I'm going to call CodeView directly. So here I am in the body, and it's complaining because I got rid of view for code. So this is now CodeView with the code being the master code. And CodeView also takes the selection. So I have to provide the selection here. All right, if you remember from CodeView, it's data in up here and data shared with me. It takes both things. And that's because the CodeView, you can tap on it, and so it can change the selection. And it also has to show the selection as well. All right, so we're going to do the same CodeView code trick for all these view for code. So this one right here, okay, CodeView code. This one, CodeView code. And of course, they all need the selection as well. So we'll grab the selection here, copy, paste, and paste. This is much nicer code, in my opinion. I like that I've got all helicopter views in here, essentially, instead of having that view for code guy in there. And this all works fine. It's just that I have no guess button, right? Because I punted on that. I commented it out. And if I were to guess, I would have no match markers either. Because over here in CodeView, this is all commented out. So how am I going to replace this commented out stuff with something configurable, something that I can put any view I want in there, kind of like VStack does, right? VStack, its last argument is the content, the bag of Lego, and you can pass anything you want in there. And VStack will arrange it in a vertical stack. Well, I want the same thing here. You can pass anything you want into CodeView, and it will put it in this little square right here at the end of the CodeView, right here, or right here, or right here. So do you understand what we're trying to do? So we're going to do this exactly the same way VStack does it. We're going to pass a view into our view and put it in there. And it can be any kind of view. I'm going to start with this by trying to come up with an argument to my code view where I could pass it a view. How about something like this? I got to call this view something. It's kind of like a little helper view or a little ancillary view. You all know the word ancillary. So I'm going to call this my ancillary view. That's what this little view that I'm going to put in there, the guess button or the match markers, call it ancillary view. And you might think that the right type for it is like some view, right? I want to pass some view in there, but this does not work. Why doesn't this work? Just say some view here. Well, some view has to be resolved by the compiler to be some specific view. Just like we had in var body right here, it looks inside the code to var body and it figures out what view is actually in there, right? A tuple view or something like that. It goes and figures it out and then it sets that to be this value. Well, here I don't have any code for it to go look at, so it has no idea what that some view is. So that just doesn't work, unfortunately, to have some view here. So what view am I going to put here? I'm just going to call this my ancillary view. I just made that up, ancillary view. Well, what type is that? Am I going to have to go create a helicopter view called ancillary view to pass in there? VStack doesn't make me go define something called content or something like that. So no. But this view, whatever it is, this ancillary view, does CodeView care what that view is? Does it care whether it's a guess button or markers? No, it absolutely doesn't care. So what do we do when we want to use a type in another struct and we don't care what it is? That's generics. That's like array, can have anything in it, ints or strings or whatever. So we are going to make our code view a generic struct. I'm just going to put here angle bracket, just like array does, ancillary view, and I've made CodeView be generic, and it's got this don't care called ancillary view. It doesn't care what it is, and now I can use this var, okay, this little let ancillary view anywhere I want, and it could be any type. So let's go down to where I want to use it, which is in this overlay. So instead of overlaying this match markers and the guess button and all that, I'm just going to overlay the ancillary view. Ancillary view. Just overlay that on top. And so now do you see how someone can pass me an ancillary view? And I'm just going to overlay it on top of that spot, just like I was doing with the match marker. But uh-oh, didn't work. What's this error? Build expression is unavailable. It says this expression does not conform to view. Just because I called this thing ancillary view doesn't mean it is a view. It could be anything. It's a don't care. I don't care what it is if I'm CodeView. Well, it turns out I actually do care, don't I, if I'm CodeView? I care a little bit. It can be anything you want, but it has to be a view, right? It has to be a view. So how do I specify that? Well, in my little generic statement here, I'm going to add a very special keyword here, where, and AI is ahead of me here, ancillary view behaves like a view. So I've just put a little where statement there that makes my don't care be, well, I care a little bit. I care that it is a view. And that made this error go away down here. Yeah.
So what's the difference with having something in there and then the colon that to say that it behaves like that or it follows that protocol?
So what's the difference between the angle brackets ancillary view and the colon view right there? So angle brackets ancillary view, that's like array contains an int. It's the element of a generic type. Remember we talked about how arrays, they can have any type in there? That's what the angle bracket is. It's just giving a name, and it can be any name we want, a name for our don't care, the thing we don't care about. Array calls theirs element. We call ours ancillary view. And then the view, that just behaves like a view. That's the same thing from the start. That just means that our struct has a var body, and it behaves like a view. So this little where ancillary view restricts our don't care to make sure it behaves like a view. And so now everything is good. And now we can actually go back to codebreaker view over here. And when this compiles, it's going to say, oh, missing argument for parameter ancillary view, of course, because I added let ancillary view. So I have to provide that argument. Well, let's see. For this one, right down here, this guess, how about ancillary view what? What should I put here? This is my guess. Guess button, yeah. Guess button. That's a view. That's the one I want there. How about down here with our attempts? How about ancillary view? What does it want? Match markers, right. Match markers, matches. This is the game.attempts of the index dot matches. And if it's nil, I'll just pass empty matches right there. But that's an ancillary view, a match markers view. And then what about master code? Ancillary view. What is this? Well, it's nothing. The master code has nothing there. So I'm going to show you another SwiftUI view, perfect for this case, which is empty view. Empty view means an empty view. So I'm passing that as the ancillary view for the master code. But uh-oh, what's this error? Static stored properties not supported in generic types. So we have a generic type. CodeView is now a generic type here because we put this on here. And what it's saying is you can't have an embedded struct inside of a generic view. And part of it is because embedding a struct inside of another struct is a namespacing issue. And the name of CodeView now kind of includes the name of the type that is its generic type. So the bottom line is we have to take this out of here, but there's no problem of just putting it in the same file. And we can even do better than this in terms of namespacing by making this struct be file private. File private is a keyword you can put on something that says this thing only exists in this file. So if someone else had a struct selection somewhere, it wouldn't conflict. They can have their own. So we're kind of namespacing it to this file instead of namespacing it to CodeView. Yeah. Yeah, so the question is how would we decompose this? Because it's getting so big that you're hitting the view builder can't build problem. I would definitely take this out of here and make that be either a var or a helicopter view, which is peg selection or something like that. I might even take this out of here and call that something like master code obscurer or something like that. I might take this out of here even, call a function called select, because that's what it's doing. You're tapping, it's selecting. So that's what I would do. I would pull those things out. So this is working, hopefully. Let's go over here and see if it's working. Oh, I got a guess button. So that's already good. Let's try putting some things in here and hitting guess. Oh, we got some match markers. That's good. And nothing is showing up over here. So voila, just like that, just a couple of lines of code, we have made it so that this little view over here is now completely configurable to be absolutely anything we want. And in fact, we'll set the one for the master code to be something in a second just to even see how that's working. But before we do that, I want to do one other thing to be more like VStack. I want this view to be a view builder. If this is a view builder, then for example, over where I do this, matches, let's clean this up so you can see it better, the arguments to this code view here. See, I'm passing this ancillary view as that view. But if I had a view builder here, I could do open curly brace, if let matches equal the code matches, then do it just like I was doing before, right? But I can't do that here because I'm passing a view, not a view builder. So I can't do the curly brace here. But what if I wanted to? You go back over here and you just change this to be an @sign view builder. If you make that an @sign view builder, now this var is going to be a view builder. But view builders can only apply to functions. Think about how view builder works. It takes a list of views, it packages them all up into a tuple view or whatever. It needs the context of a function to go do that work. It can't just be a static view like this. So we have to change the type of this thing to not just be ancillary view. It has to be a function that takes no arguments and returns an ancillary view. So now that that's a function, we can apply view builder to it. You see why we had to do that? Now you see why VStack takes its argument as a function, its content argument. This is why. And of course, it changes it down here. I can no longer just include ancillary view because it's a function. So I have to call ancillary view. And that's going to return to me the view builder, whatever it is, and I can put it in here. Everyone cool with that? So now let's go back to code breaker view here. Now we're passing a view where we're supposed to be passing a function, right? A view builder function. So let's do that. Like, how about here, this empty view? Watch this. I'm just going to go curly brace, empty view, close curly brace. Is that a function that returns a view? Yes, it is. So it's totally valid view builder. How about this one right here? Let's use trailing closure syntax. What about this? Curly brace. Put our guess button in here, like that. Voila. That looks just kind of like VStack does. No compile problems, it's all good. Same thing down here. Now we could go back to what I was talking about before. We have this, and I could say if let matches equal this game attempts that index dot matches, then I could just pass in here matches. I don't have to do this question mark thing. So that's a view builder. I got an if in there. If in the middle of the thing I'm passing is my ancillary view. And of course I could do trailing closure syntax here as well. Let's go here, close that up, get rid of that. Okay. Yes. Actually, may even make this look nicer by putting this on one line since it'll fit now. Doing that, and we'll even move that back. It's pretty cool looking code right here. This code looks really nice. It's got all the fundamentals of what's going on with no other cruft. Okay, it's all exactly the stuff that's actually in this UI. How about changing this empty view of our master code to something else? Let's get this out of here. How about this? Look at this. 003.font.title. See that 03? Imagine if that was counting how many seconds you've been playing this game. We could have an elapsed time thing, right? Now, I'm not going to do that today because I need to go do this animation slides, but we'll do that next week. We'll go ahead and do a elapsed timer, and that's where we'll put it because it's a great place for it to fit. And of course, yes, we would and could do trailing closure syntax here as well. But we're not quite done. One thing I want to do here is get rid of the fact that I have to pass selection : $selection here in my master code when I don't have a selection. There's no selection in the master code. The selection is here in the guess code. And same thing here. I don't have a selection in my attempts. It's annoying to have to pass that when it's completely not being used. But we got a problem. In CodeView, this is an @sign binding, okay? And I told you can't say equals something, so you can't give it a default value. You're just not allowed to do that. So how the heck are we going to make it work to default that thing somehow? The answer is we're going to use an init. We did inits in our model, but we can do them in our views also. So I just did init and hit tab twice to let the AI come up with it, and it blew it. It came up with something that's close, but it's not right. It's got quite a few little problems here, so let's fix the errors that this thing came up with. The first one is that it thinks that when you initialize a code view, that the selection you should pass is an int. But what is the type of a selection when we pass it to a code view? Anyone know?
Binding.
Yeah, it's a binding to an int, in fact. So this type really needs to be the type binding, and it's also generic, to int. That is the type, when we do $ selection, we're passing a binding to that int. We're not passing the int itself. But now look at this line of code doesn't work. It's saying selection equals selection. Well, self.selection is the little computed property that this @ binding makes that knows how to go and get the value from somewhere else and set the value from somewhere else. So it's not of type binding of int, it's of type int. It's a computed property of type int. But I told you that @ binding makes another secret variable that you don't see that is actually the binding of int for this, and it's called underbar selection. So here we need to say underbar selection equals selection, because we're passing the binding in, we need to set it to that underbar thing. The computer property will still work just fine if we set the underbar thing, the binding that's actually doing the work. So this is the one time you actually do access that underbar thing, is when you're in an init and you just passed one in, you have to set it. Otherwise, you don't usually need it. Now what about our ancillary view here? It thinks the return type is view. Good job, AI, but you're fired because it's actually ancillary view. Didn't figure that out for some reason, although it did get this right. @escaping. And why does @escaping here? It's because we're not using this function in here. We hold on to it and use it down here, okay? Anytime you don't use a function that's passed to another function right there, you have to say @escaping, meaning it escapes this init by hiding in a var, this ancillary view var. So it did get that right, which is good. Now the other thing we want to do here is, this is an @view builder right here, but now that we have an init, you can't set this directly. So it's really no use to put it here. We really need to put it here, @view builder. And again, I showed you this actually in the very first lecture. This is what HStack and VStack do. In fact, let's go look at HStack and VStack's documentation. Option click on HStack, for example. Look at this. Content is a function that returns a content, and down here it says that HStack is generic over content, where content is a view. That's exactly what we're doing. We're doing exactly the same thing, but for us, we call our thing ancillary view instead of content. See that? Now, when we go and look in HStack's documentation further, and go look at its init, for example, here's its init, look, it's put view builder on its content. And if it doesn't put it here, then whoever's creating CodeView, that side of the equation, the compiler doesn't know to view builderize it, to tuple view it, and all that business. So that's why it has to put that there. So we're going to do the exact same thing. Put our view builder right here. Oh, sorry, yeah?
Can you put in the underscore before selection?
Yeah, I'm glad you asked about this, because this does kind of make people go, what? Underbar? Okay. Here's the thing. When you do @binding var, this thing here is a macro. It's actually doing some other code somewhere. It creates two vars for you. Two. One is this var selection, which is a computed var, and then it creates another one, underbar selection. You don't see it, but it's there. Underbar selection. It's of type binding to an int. It's the struct that's actually doing the work. The other one, the computed one, is just using that thing. So when I pass a binding int into an init, and I want to set that as this thing's value, I have to use its underbar one, because I'm actually setting the binding, not the value, but the binding to the value. Does that make sense? So it's a little tricky because it's hidden. You don't see that underbar selection, but you could imagine that there's a little var underbar selection of type binding int. That's there. You don't see it, but it's there. We're setting this var. All right, so we did all this init stuff so that we wouldn't have to say back here selection : selection if we didn't have a selection. So now that these are an init, we can just start defaulting these arguments. So I'm going to default this one to be, by default, binding of an int dot constant -1. Okay, -1 is good. That's what the AI suggests. I'll go with that. Our pegs are obviously 0, 1, 2, 3, or whatever. So -1, that's going to constantly be not anything selected. So that's a good constant to set it to. And of course, I can use type inference here. I don't need to put that there. can infer that it's obviously a binding of an int. And remember I told you in the slides about .constant. It's just a way to have a binding to a constant value. I can also default this one, this ancillary view, because what if I'm like master code and I don't want to specify it? I'm not doing the elapsed time, so I don't want to specify it, let's say. Well, I can do that as well. So let's actually make this easier to read by putting it on separate lines, because these are so long. So I'm just going to say that this one equals empty view. So I provided by default here a view builder, a function that returns a view, and it returns an empty view. So that's the default. So now if I go back to CodeBreaker view, and for example, for my master code, if I take this off, still compiles, because the ancillary view defaults to being empty view. And I can also take this off, because the selection defaults to -1. And in the master code, there is no selection, so we don't care. And same thing down here. In my attempts, I take that out of there. So now my code reads even cleaner, because there's nothing on here that's not actually happening. And that's a really key thing if you're writing clean code. Try to make it so there's no keywords on there that aren't actually doing something, because it helps people reading your code to focus on what's really important here. Let's make sure we didn't break anything. Here we go. So code, guess. Oh, we're getting match markers. Yeah, there we go. Guess. And let's even go and cheat. What do we got down here? A green, brown, green, black. Green, brown, green, black. And guess. And it's working. And everything is fine. So like I said, that's a little bit advanced data flow or whatever you want to call it. But it's important to understand that's how HStack and VStack and these things are, or for each, all these things that are taking views as view builders, that's how they're doing it. They're generic types. They're generic views. Back to the slides. All right. So animation, you can see there's a lot of things up here. Let's just dive in and start talking about them. But actually, before I get into all of these things, let's talk about animation in general. First thing to really understand about animation is that only changes can be animated. All right? Only changes. That's what animation is. It's showing the user something that has changed over a little bit of time. Half a second, 1 second. It's a pretty short amount of time, but it's showing you changes. So what kind of changes are we showing? Well, there's two big ones. The arguments to view modifiers. That's the number one thing that we can change that's going to cause the screen to change. Like its opacity, and we change it from 0 to 1. Well, it's going to fade from not visible to fully visible, or vice versa. Or we have a color, and we change it from blue to red. Well, it's going to be blue, and then it's going to turn a little bit purple, and then it'll go over to be red. Okay, it's going to be animated. Those are changes. We're changing something. The second thing that is a big change is we take a view off screen. Or we put a view on screen. We want it to fade in or fly in from the side, or maybe zoom up or something like that. We want it to be animated, the appearance and disappearance of views. And in CodeBreaker, we have a lot of views appearing and disappearing, right? We make a guess and a whole bunch of new pegs appear. And when we're actually clicking on the selection, we're moving to different views are appearing and disappearing because each peg has its own background. And so it's appearing and disappearing. So those are the two major things. Most animation is about that. Now, the third thing, which I'm hardly going to mention, is shapes. Okay, shapes know how to animate changing their sizes and things like that. Okay, obviously, they have to be. Otherwise, if you had some view that got smaller and had a circle in it, you wouldn't want it to jump to a smaller circle. You want it to smoothly go. So shapes, but very unimportant. But the first two things are what we're going to focus mostly on. Now, another thing that's really important to get in your brain and kind of think about this animation thing is that animation is showing the user something that has already happened in your code. So if you change a foreground style from blue to red, in your code, as soon as you say equals red, it's red. It's not purple or something along the way, and it never is in your code. It's red, instantly red. It's just that the user doesn't get to see it until half a second later while it goes from blue to purple to red. You see what I'm saying? So get this in your mind that in your code, everything's happening instantly. As soon as you assign a variable, change your model, you changed it right then. Maybe the user sees it over the next half second or so, but you've changed it immediately, all right? So these two things I want you to always have in your mind as we talk about all these things that we can do in animation here, all right? Okay, so let's talk about animating view modifier arguments. Okay, this is like view modifiers are the number one change agent in all the UI. And in fact, even that thing of when we're removing views and stuff, that's actually animating view modifiers too. But anyway, most animation that you're going to see is a change to a view modifier. Okay, now not all arguments to view modifiers are animatable, but most of them are. Okay, even things like fonts didn't used to be, but you can change them now and it will animate those as well. One thing about changing a view modifier's arguments, though, if you want it to be animated, it has to happen after the view is put in the UI. Okay? In other words, only view modifiers that change in views since the view joined the UI will be animated. Does that make sense? If a view's coming on screen and at the same time its view modifier arguments are changing, no effect. Now, the view coming on screen is going to be animated separately, but the view modifiers, none of that change. Okay? The thing has to already be sitting there on screen, and then a view modifier changes. That's view modifiers. The other one is views appearing and disappearing. How do I make that happen? Well, you already know how we make that happen. For each makes this happen, because for each is a collection that is making a view for each of the things in the collection. If the collection changes, the views are going to change, right? If the collection loses an item, a view is going to go away. If you add something to the collection, a view is going to appear. So views are coming and going there with for each. And then, of course, if else. If you have an if-else in a view builder, and the if becomes false, that view goes away. So these are the two primary ways that you make views appear and disappear. We call the appearance and disappearance of views transitions. And there are lots of different kinds of transitions. The default one is to fade in and out. That's why when we added a little bit of animation to CodeBreaker, our pegs would fade in and out as we made guesses. They faded because that's the default. But there's other kinds of transitions, moving, scaling, zooming around, that kind of stuff. Now, a transition, that animation, is performed in the context of its containing view. This is important to understand. So just like a view modifier that changes will have no effect on animation if that view is not already on screen, same thing with transition. A transition will have no effect on animation if its container is not already on screen. Animation can only happen to things that are already on screen. I can't emphasize this enough. And when you go start doing your homework and start doing it, you'll start struggling with it and you'll see, oh, I see why he was saying that all the time. But it's a really important thing to understand. Another way to say it is that a view that's coming on screen can only be animated if it's joining a container that's already on screen. Or similarly, a view that's going off screen will only be animated if it's leaving a container that's staying on screen. Make sense? So how do we make animation happen? Well, we do it by changing things, changing our model, changing @sign state. When we change things, animation starts happening. Why? Because our view is a manifestation of that data. And so if the data is changing, then our view is going to draw something different to manifest that change. And we want to usually animate almost all those kind of changes because we want our UI to be smooth. You never want your user saying, what just changed? It's one of the worst things your user can possibly say if they're using your app is, what just changed? Because something happened rapidly and they can't figure what it is. And animation helps them with that because it slowly comes in. It draws their attention and then they see, oh, that thing appeared. That's why we have animation, really. Now, that's the only way you make things happen is by changing things, but you can control how those changes appear on screen. Is it a fade? Is it a slide? Is it a zoom? You can control those things, obviously. And there's 3 or 4 different ways you can control it. One is called implicit animation. And you do this with a view modifier. We're going to talk in detail about it in a couple of slides. But it's essentially a way of tagging a view and saying, when certain changes happen to this view, animate it in this fashion. That's basically what implicit animation is. You put it a lot on Lego bricks. You don't tend to do it as much with containers. The second kind of animation is explicit animation. This is where you say, animate this. And we've already done this with animation is how we do explicit animation. And what happens is you're telling the system, I'm going to do something, change my model usually, or change the @sign state at least, and I want you to animate everything that changed because of this. I mean everything. You can see very different things here. The modifier, which is really focused on one view or a little small space, and then with animation, which is I'm making a big change to my model, animate it all. That's what we did in our thing so far. And then a third thing is animating transitions. This coming and going of views, you want to be able to specify how this view appears and disappears. Does it fly off the screen or does it fade out or whatever? So that's transitions. We use a view modifier for that as well called transition. And then the last bit of animation, I've used timeline view actually just as an example of it. This is actual animation, like guy running across the screen or something like that. That is not the animation of your UI in action. That is just some actual animation. And of course, there's massive animation engines built throughout the whole SwiftUI infrastructure for building Mario Kart or whatever kind of animation we do. We're not talking about any of that here. We're talking about making your UI smooth. The buttons do smooth actions and colors changing smoothly. That's what we're talking about. But timeline view, I will briefly talk about it. It is something that can do the guy running across the screen kind of animation. And I'm going to say it again, that all of these things that we're going to do, these view modifiers and with animation, have no effect unless this view is already on screen at the time the animation change happens, the change that causes the animation happens. All right, so let's talk about implicit animation first. This is the view modifier. It's called animation. You can see that it has two arguments in green there. The first argument is an animation. That's a struct. We're going to talk all about it. This is the thing that controls what the animation looks like. But it's got a very important second argument there, value, whose type is sum-equatable. That's actually its type. And that just means it's any type as long as it's equatable. You can use this animation thing to make it so that some specific view always animates when the value changes. You can also use it to suppress animation when things happen, because this argument, really, the green argument, is not just animation, it's optional animation. I should have put a question mark there, because it really is animation question mark. You can pass nil, which means don't animate when this change happens. I'm going to give you a long sentence here that defines animation view modifier, and I want you to pay attention to every piece of it. The first one is that it declares an animation. This is declarative UI we're doing here. All we're doing is declaring what animation to use when this value changes. Animation doesn't cause animation to happen. Changing things in your model causes animation to happen, all right? This view modifier is going to override other animations. So if you have animation going on because you have a view modifier, it's going to happen. It's like the winner. Compared to, for example, with animation. With animation might be trying to animate something a different way. This one will win. It animates everything, all changes to view modifier arguments and all transitions that change as a result of the value changing. And this is a huge part of this sentence. This animation thing is only going to cause things to be animated if value changed. That's why it has that value. That value is really what we're animating. This view modifier basically says this is the animation to use when the value changes. Not when the things change on the view modifier arguments or when things come in and out and all this stuff. Now, value might be causing those things to happen, but only the things that value causes to happen is going to get animated. All right, so we are animating that value here, really. That's crucial to understand. And another crucial thing to understand is inside the view it modifies. This is a view modifier. So this is only going to animate things when value changes inside that view, or things that are contained by that view. It's not going to animate things like view modifiers that are after that animation. Okay, the order of view modifiers matters, as we know, and it really matters here for animation. So it's only going to animate things that are inside the view that it's modifying. And finally, of course, the view has to be on screen at the time value changes. When the instant value changes, if that view is not on screen, no animation will happen. So this is what the animation modifier does. So let's see an example of an implicit animation here. I have text hello. It's got a foreground style, which is red when a var that I have called warning is true, and it's just the primary color, black or white, depending on dark mode, light mode, otherwise. And then I have a font, which is large title if I have my big variable set to true, otherwise it's tiny little caption font. And now I'm going to implicitly animate this whole green construct. And I'm going to animate with an ease in, ease out animation. Hold your breath on that. In a couple slides, I'm going to talk all about animation struct, but this is an animation struct, ease in, ease out. And the value is warning. So this line is going to animate anything that changes in that green thing up there as a result of warning changing. which we can see that the foreground style is going to change, but look, the font is not going to change. So all we're doing here is declaring or marking this view to animate automatically when warning changes. And then the real takeaway here is that font is not going to animate from a large font to a small font there or vice versa unless big were somehow being set at the same time as warning. Because changing warning, unless there's some code we don't see that involves big, is not going to change big. And so that's not going to have any effect there. Even if big changes by itself later, it's not going to be animated. This animation does not animate changes to big. It only animates changes to warning. All right, so let's take this one step further. So this is the same code. I'm going to add another line here, which is dot padding. So now, when there's a warning, I'm going to make the thing be padded. That is not going to animate, because that animation is before it. So the padding view is not being animated. It doesn't even have a dot animation. It would need like a with animation somewhere to cause it to be animated. Even though the padding does depend on warning, it doesn't matter because it's after the animation, so it has no effect. And let's go another step and add another animation after the padding. This one depends on the value big. So this is going to animate that font. Anytime that big changes and the font goes from large to caption size, it's going to get animated. But it's still not going to animate that padding because that padding is not big. It's driven by warning, and it doesn't have an animation driving it. That animation is before. So the order here, super important. Now, I want to just give you a warning here about container views. Can you put a dot animation on a container view? And what does it actually mean to put it on a VStack or an HStack or something? And the answer is absolutely, you can put it on there. And it propagates the animation basically like a dot font modifier would. So it's like all the things in the bag of Lego also have that same animation. It kind of needs to do that because part of the definition of animation is that everything inside of a view would be animated. However, I'm going to say that this is kind of weird. And when you write code like this, it can actually be kind of confusing what's going on. So I recommend against generally using animation on container views to mean I'm trying to set animation on all the things inside. Go ahead and set animation on all the things inside. Be explicit about it. However, there is a time when animation on a container view does make very much sense, and that's if you want transitions inside the container to get animated. You see why? Because the container itself, if it's going to be animating the views coming and going inside of itself, it has to be animated. It sometimes does make sense to put an animation on a container view when you want the transitions, views coming and going inside of that HStack or VStack to be animated. Now, do we do this very often? No. Why? Because we use a lot of explicit animation, right? We use a lot of with animation, so we don't need these things. And I told you that this animation modifier is more for smaller things. Like in the demo on Wednesday, I'm going to make our selection, the little gray box that moves around selection, I'm going to animate it. I'm going to use dot animation because it's kind of a contained small thing, and no matter what I'm doing with guessing or restarting my app or whatever, I still want that thing to always animate the same. And that will be transitions inside of a container view. Okay, so that first argument to this animation view modifier is an animation struct, so let's talk about that. What is this animation struct? You can control things about your animation like the duration. Is this a 1 second animation or 2 or half second, tenth of a second? How long does this thing take to play out? You can also delay the animation slightly. Remember, animations always happen after the fact anyway, so you can make them a little more after the fact where they don't even start showing anything for half a second. That's perfectly allowed. You can also make animations repeat over and over, which can be kind of weird because you change from red to blue, and now it's blue, but in the UI it's going red, blue, so you can go back and forth. It's weird because it's blue in your code, but you can do it, all right? We don't do that much. But the most important thing about an animation is its curve. The animation curve, we call it, and this is how the thing plays out over time. Now, the easiest curve to understand is the first one there, linear. So a linear curve, if I'm going from red to blue, starts out red, then it's going to get purple, and then it's blue. But ease in, ease out would be it slowly goes to purple, then quickly goes to purple, and then slows down at the end, and then becomes blue. It's kind of easing into it, and then it goes quickly, and then it goes out. Now, ease in, ease out is mostly for moving things on screen. You have some square here, and it's going to move over here. It doesn't just go beep. It goes kind of slow, and then it zips over, and then slows down when it lands. Just a little less abrupt than jumping around. So that's mostly what ease in, out is used for. And then we have spring and bouncy. That's where something moves across screen, and then it lands, it kind of wiggles a little. It kind of has like a little spring on it, and that just makes a softer landing also. And that also is mostly for movement, for things moving. And there's other ones too. If you look at the animation struct, this is something you're going to want to go do your homework and look at the animation struct. You'll see all of these different kind of animation curves that we can use. And we're going to, of course, see it in the demo on Wednesday. So let's talk a little bit more about explicit animation here. These implicit ones, like I say, they're mostly for leaves. We don't tend to put them on containers that much. And they're also mostly to animate things that are kind of independent of everything else, like moving the selection when I tap on things. That's independent of guessing and restarting and all these other things we might animate. So most of the time, animation happens because the user asks us to do something substantial. Usually change our model, like guess, or like restart my app. These are substantial things the user is asking me to do, and I want to animate the whole thing. And the first way I'm going to do it is with these explicit animations, which is going to give a first pass animation. Then I'm going to tweak it, tune it with dot animations and with some other things that I'm going to show you here where you can turn on and off animations and stuff like that. So let's talk about explicit animation here. And we've already seen this. You have this with animation. It has a block of code, and it's going to animate everything that changes from that block of code. Now, the one I showed you in lecture is a very simple version of with animation. Here's the more complicated version of it. You can see that with animation can take the kind of animation you want. Linear, or ease in, ease out, or springy, or whatever you want there. So here I have linear in this example. And it also can have another little code block called completion. That code block will be executed when the animation completes. This way you can do chained animations, like slide this thing down here and then make it fade out. Two-step animation. You can even go multiple steps, because inside that completion, you're probably doing another with animation in there. You can nest it with animation as much as you want. And we're going to wrap this around almost every thing that the user asks us to do. It's pretty rare that we have a user gesture, like tapping a button or doing something like that, and we don't do a with animation at that time. We want our animation to generally be coordinated. Now, with animation is kind of a big hammer because it causes everything that changes to be animated, but you kind of have to have the big hammer, and then you can chisel off the little fine pieces with that dot animation thing and some of the other things I'm going to show you here. With animation is our main explicit go animate this next thing that I do. Important note here, explicit animations do not override that animation view modifier. So if I am animating my selection with dot animation view modifiers, when I do guess or attempt, maybe it sets a different animation curve or a different duration, it's not going to change the way my selection clicks because I'm doing that with the view modifiers. And you need it this way because, again, the with animation is a big hammer, and you need to be able to fine tune it, and you do that with the little dot animation view modifiers. Let's talk a little about overriding animation, because you got this big hammer, it's causing everything to animate, but some things you don't want to animate for some reason, or you want to animate a little differently or something like that. Well, of course you can do it with dot animation, and in fact, one trick is you can say dot animation nil value whatever, and that can stop animation from happening when that value changes in that view that you put it on. So that's a way to suppress animation. But another way to suppress animation or to change it or modify it is with transaction. Here is transaction. Now, I'm not going to go into details about how SwiftUI does what it does. But essentially, when data changes, SwiftUI makes a pass through all your views, and it looks at what changed, and it decides which var bodies to remake. And it's actually looking in your var bodies to see what data you're looking at. And if you're looking at some data that changed, it's going to make your var body again. Well, it does these in passes, state change passes, basically. And when it does that, it creates a transaction. So a transaction is just a struct. You can look it up in the documentation. The main thing that's in it is the var called animation. And that's the animation that's going to be used for that state change pass. So when you say with animation, give it an animation, and then you do a block of code, it sets up a transaction with that animation you want for that entire change of state. Now, .transaction, the view modifier, you see right there in yellow, it allows you to change the animation in that transaction thing just for this view. And since it's a block of code right there, since it's a closure, you can do it under certain circumstances by putting ifs in there. So you're handed the transaction. You see that that closure has an argument, right? Transaction in. So you're handed the transaction, and you can then modify it, and it will only apply to the view that you're modifying. In this case, my code view right there. So this little code that I have would make it so that my master code never animates. Because I'm saying .transaction, if the code kind is master, then the transaction animation is nil or none. So we'll use no animation. No matter what I'm doing with it with animation, this is going to shut it off. Now, you might ask, when would I use .animation to suppress animation, and when would I use .transaction to suppress animation? Well, it's actually easy. Animation, you're going to use for suppression when you want to suppress as a result of a change. Because animation has that value thing, and it only does its thing when things change. Transaction, you're going to suppress animation or enhance animation based on some state, like am I the master code? I'm not changing. I'm the master code or not. Okay, it's state. So it's state versus change. That's the difference between these two. All right, now let's talk a little more about transitions. Transitions are, as we talked about before, this arrival and departure of views. It only works inside these CTAAOS. I've made that intentionally obnoxious little acronym there, but it's containers that are already on screen. That's the only time a transition will work, is if the container it's in is on screen. We already talked about this before. Under the covers, a transition is really just a pair of view modifiers. A view modifier that describes the state before the thing disappears, and another one defines the state after, presumably like with opacity 0 or its position is somewhere else. And then same thing the other way around, view modifier before it comes on screen, and then another view modifier when it gets on screen. And then transition animations are just animating between the two view modifiers. But that's all under the covers for you. You don't see that because there's a layer on top of all of that called any transition, which I'm going to talk about, which kind of abstracts all that away from you. It makes it really easy to use a transition. Transitions can be asymmetric. In other words, it's perfectly fine for a view to fade out but come back by flying in, or zoom in and then just disappear instantly or fly up. You know, I mean, they can be asymmetric. And an asymmetric transition is just itself a kind of transition. It's just that its arguments are, what do you want for the insertion transition and what do you want for the removal transition? You'll see that in a second here. We use this any transition struct. It does something that we call type erasure, because we do not want to be thinking about the types of all the view modifiers and all the stuff that's going on under the scenes to do these transitions. So instead, we use this any transition struct, which is what you're going to look up in the documentation. It's called any transition. Kind of weird. And when you look on any transition here, you're going to see all the different kinds of transitions you can do, like any transition.opacity, which is fade in and out, any transition.scale, that's zooming in and out. You got any transition.identity, that's no animation. And the reason that's called identity, anyone guess why it's called identity? Yeah, because the two view modifiers are the same. The one before and after, they're the same. They're identical, and so no animation will happen between those two. There's offset, that's moving the thing, probably off the screen. And then move to edge is kind of fun. You can move the thing to the leading edge to make it disappear, or move it to the trailing edge, or top or bottom. And then the bottom one, modifier, active, and identity, that's specifying the two view modifiers, the before and after, which again, you're not going to be doing that. You're just going to use the pre-canned ones. And there's other pre-canned ones. So just like I said, go look at animation, go look at any transition too, so you can see what kind of transitions you can use to make views look beautiful as they come and go. So how do we specify which of those things we want for a given view when it comes and goes? Well, we use .transition. .transition is a view modifier. It declares which of those transitions you want to use when this view disappears or when it appears, or both. And you can use asymmetric transition to have those two things be different. So here's a good example from our game. Here's a simplified version of our attempts. We got 4 each, our game attempts, and we make a code view for each of our attempts. And I've made the transition for the code view to be that when it appears, it flies down from the top, and when it disappears, it instantly disappears, because I used identity. Now, in the demo, I'm going to use something different there, but I am going to use an asymmetric transition, but not this one. But I just use this to show you the blue and the pink, those are themselves any transitions. They're any transition dot asymmetric, any transition dot move, any transition dot identity. So that's how we specify transition. So now anytime that for each, because its collection changes, causes the code view to be added, like when we hit a guess, it adds it to that collection, creates that code view, it will transition on screen with this insertion, which is moved from top. Okay, and when we hit restart on our game and it gets rid of all of our code views, they'll all instantly disappear. Transition here is a view modifier. It's a noun. This is the transition to use. This is not cause my view to transition, please. We make our view disappear with if-thens and for-eaches. All right, match geometry effect. This is another transition thing, a little different. We don't use dot transition for this. This is when we want to move a view across the screen from one place to another. Now, if the two views we're trying to move are in the same container, no problem, because containers usually put their views in their place using the dot position, which we've not seen, but there's a dot position view modifier which says where this thing should go in the container. That's how HStack positions things. It sets dot position on its little things in its bag of Lego. And if they're in the same thing, it's no problem because dot position is just a normal view modifier and it animates normally. Things slide across the screen, so it's just nothing. If they're in the same container, animation is trivial here, just dot position doing its thing. But what if the two views are in different containers? That's a lot trickier here. You can't use dot position if they're in different containers. To do that, you want to essentially have a special transition where when one of them disappears and the other one appears in the other container, instead they fly over. The view that's disappearing flies over to where it's appearing. Normally, if you didn't use this kind of match geometry effect thing I'm going to talk about, then when one disappeared and the other appeared, the default is fading, so one would fade out and the other one would fade in. Well, that would look horrible. So you want it to fly over. Now, what's an example of this? We have one in CodeBreaker, our selection. When we tap on the selection, it's actually causing a background view on one peg to disappear and then a new background view to appear on the other one. So that's views coming and going. So if I wanted instead for the thing to slide over as I clicked, then I'd have to use this match geometry effect, and I'm going to, okay, on Wednesday to show you how this works. So what does it look like to do match geometry effect? It looks like this, dot match geometry effect, not dot transition, but dot match geometry effect. And there's really only one argument to it, which is that ID. The reason it has that second thing in namespace is because we want that ID, which can be anything, string, int, I think it's anything that's hashable maybe. We want it to be namespaced so that if two different views are using selection as their ID, which is what we're going to use for our selection, they could each have their own namespace. And you create a namespace by doing @namespace. So if you do @namespace private var namespace, it just creates like a cookie, you know what I mean? Like a namespace cookie that you only use for this purpose, to namespace your ID. So anyway, match geometry effect, you give it this ID, and you're going to put match geometry effect with that ID on both of the views, the one that's disappearing and the one that's appearing. And often it's the same view, like it is in our thing. It's our little background view. But you put it on both views, and then what happens is you make sure that only one of them is ever in the UI at a time. And as long as only one of them is ever in the UI at a time, they'll fly to each other as they appear and disappear in pairs. Now, it is possible to have match geometry effect where the two views are on screen at the same time. But then there's another argument to match geometry effect called isSource, which says which of them wins. Right? Because they're sharing their geometries. So if they're both on screen, who's the winner there? And so you would have another argument there. We don't use that very much. Match geometry effect is much more used for exactly what I'm talking about, where one's disappearing and the other one's appearing. But it is possible to use it to line up things, have them match their geometries, essentially. And it matches not just position, but also size. So if it disappears one space and it's like a little icon view of it, and then it appears in another place where it's the real thing, it'll zoom it up to size, too, which is kind of cool. All right. On appear, one of my favorite view modifiers. So on appear I talk about it in animation because you can't kick off an animation until you're on screen, right? If you're a container and you've got something going on inside, you got to be on screen. So onAppear is a way for you to put a view modifier on a view that will be called as soon as that view comes on screen. So it's as simple as that. That's all onAppear does. As soon as your view comes on screen, it's going to execute some code. You get to say what the code is. And this is great for kicking off animations because as soon as you get this, you know you're on screen. And so now you can start kicking off your animation. onAppear has just this one argument, which is a closure, block of code. And you can do anything you want in there. It's imperative code, right? You can do with animation this or whatever. You can do non-animation things. Maybe initialize your game. You could maybe initialize your game you're working on in A3 in onAppear if you want. That'd be perfectly fine. And there's a similar one on change of, which you saw in the hints to A3. On change of is, instead of getting fired off when you appear, it fires off when something changes. So you just give it an argument, like here on change of selection, I'm giving it my selection bar, and it's going to print on the console the selection changed every time. And I can put this on change of modifier on any view that is going to be on screen at least when these things are happening, but generally I like to put them near the views that are going to do something about it. You know what I'm saying? Because someone reading your code, it'd be nice if they can see it nearby. But it can actually be almost anywhere you want in your view because it's not really tied to your view per se, it's tied to that value changing. And there's another cool version of onChangeOf, which has two arguments to its closure, which is the old value and the new value. Because in the top one, you're only seeing the new value. Because on change of, and it just told you, yes, it changed. So now you're looking at the new value. But you can actually see the old value as well. If you do the two arguments, old value, new value. Notice that they both have this initial true, which you don't have to put there. The default is false. And initial true says, it's almost like onAppear. Do I call this right when I start up? When this view first arrives, do I call it? And I actually use that, I think, in the hint I gave you, right? Because when your view starts up, I want you to look at the words, and they'll be at 0 count, and then I want it to fire again later when the word count changes. OnChangeOf is actually a really good way to manage the state changes in your app. Things are changing, and you want to do things as they change. It's a really cool way to do that. Now, I wouldn't overuse onChange. We have all the other mechanisms in our SwiftUI updating system. Let them do their job. But sometimes you need to do this. And it's also good for debugging, like this. You can print. You just want to see, oh, when that variable changes? Oh, it changed. I didn't expect that. You can have it printing out. Timeline view. Okay, so this is the thing, like I said, animating a little guy running across the screen or something like that. And the way timeline view works is you give it a view builder. This argument to it is a view builder. You can put anything you want in there, and it's going to build that view builder on some periodic schedule and draw that as its view. So the timeline view actually draws its view builder as itself, and it does it on a schedule. This one, for example, is dot every minute, and you can look in timeline view's documentation and see all the choices like periodic, and animation is a good one. Dot animation is a good time thing there. That matches up with the other animation we've been talking about. So it's the same refresh rate, essentially, as animation. And then that little context that you get right there. It's got some things in it. One of the most interesting things in there is the date of the time slice that you're supposed to do here. And you can look at that date and use it to decide how far along in this animation am I. Is the little guy halfway across the screen or whatever? That little date will tell you. But there's other things besides timeline view, phase animation. You can have an image, like a GIF-like image that has multiple states, and you can animate through those using this phase animator. And then, of course, you can do keyframe animation, which is, for any of you who know about animation, that's the fundamental kind of way to do animation with keyframes. You can do that as well. The last thing I want to talk about here, just enough time for this, is kind of how all this animation stuff really works. What's really going on underneath the covers that makes this work? And I'm not going to ask you to do any of this in this class. I don't even think you'll do it for your final projects or anything, although you are certainly welcome to. But the answer is shape and something called view modifier. They're both protocols, right? And we know that rectangle and rounded rectangle circle, they implement the shape protocol. And view modifier is implemented by a whole bunch of structs that are behind the implementation of all view modifiers. font and all these things. They all have a struct. You don't see it. You don't see the name of it, but it's back there, and it's actually the thing that is managing the modification that happens with a view modifier. Now, both shape and view modifier, those protocols, also can implement another protocol called animatable. And animatable is a very simple protocol. It basically has a var, which is the animatable data that's involved with your thing, and you just have to go through and divide up whatever your thing does, your view modifier, into little pieces. And then the animation system just plays those slices. So it's kind of like a bit of a dance, a coordination between the view modifier or the shape and these little slices and the animation. So the animation system does all the thing about the curve and how big a slice to move to next and how fast to call the things, the duration. You see what I mean? All that is done by the animation system. All the animatable thing, like the shape or a view modifier doing, is to draw its piece. First of all, how to divide itself into pieces, and then second of all, how to draw a piece at a certain spot. So that's all that's happening there, is this piecification and then this drawing. The view modifier protocol, if you look in it, it has var body as well, but it has an argument to its var body, which is content, and that content is the view it's modifying. So it can do anything it wants in its var body, but it's doing it to the argument to it, which is the thing it modifies. Makes sense, right? It's a view modifier. It takes a view and modifies it. As I said, it's pretty rare to do this, to make your own thing. I actually have done this in this class in the past, but I just decided it's not worth the lecture time because it's just not that common. There's just so many good view modifiers already. You don't really tend to have to do your own very much. All right, so that is it. And on Wednesday, we will be back here and we will apply all the things you've seen here to making our code breaker really smooth. Okay, really do some cool things flying around and spading in and out and all that stuff so that it looks nice. And then some of what I'm doing there will apply to your A3, okay? But a lot of it won't because, for example, your A3 has no match markers. And a lot of what makes our current code breaker kind of clunky when you see it work is that those match markers are like overlapping things when things are fading in and out. So I'll be cleaning up a lot of that won't matter. But there's still a lot of other stuff that will apply. And also, I'm going to encourage you to, when you come out of Wednesday's lecture, think about, oh, well, what cool thing could I add to my A3? Because you have all the way until next Wednesday to work on it. So should be a good opportunity to think of something cool, something fun to do. And there's a little bit of challenge mode to give you credit for doing that as well.